Now we're going to look at the periodic table and why it's organized the way it is. Dmitry Mendeleev published a table of elements in 1869. Now, elements in his table were arranged in groups based on a set of repeating properties, and they were in order of increasing atomic mass. Atomic mass is the decimal number on your periodic table, and it's the weighted average of isotopes. So atomic mass is the decimal number on the periodic table. Now, at his time, Mendeleev, there were only about 60 elements that had been discovered. Today we have over 110. So he was able to leave gaps for missing elements because he arranged his periodic table in groups based on repeating properties. His was the first table to gain wide acceptance. His was not the first periodic table, but it was the first to gain wide acceptance, and therefore he's often credited as organizing or developing the periodic table. Now, today's periodic table is a little bit different than Mendeleev's. Elements are arranged in order of increasing atomic number, which is the number of protons, not atomic mass. If you look at the periodic table, you'll notice that I'm looking at number 27 and 28, cobalt and nickel. Cobalt's number 27, nickel's number 28. And if you actually look at the atomic masses, the decimal number, you'll see they're out of order. But we arrange elements based on the number of protons, atomic number, not atomic mass. Periodic law says there is a general repetition of physical and chemical properties because elements are arranged in order of increasing atomic number. What does this mean? Another way to state the periodic law is this. If you're in the same column, same vertical column, you have similar properties. That means if you're in the same column, for example, lithium, sodium, potassium, rubidium, group 1A, they are going to react very similarly. And that's just a restatement of periodic law. We can divide the periodic table into three main groups. First group, metals. Metals include most elements. About 80% of the periodic table are metals. Metals are good conductors of heat and electricity, so heat and electricity flow through metals rather easily. Metals are all solids at room temp, except for mercury. Now, if you look at the periodic table on the wall in the classroom, you'll notice they have different colors for the elements. If an element is black, that means it's a solid at room temp, 25 degrees Celsius. If an element is blue, like mercury, that means at room temp, it's a liquid. And if it's outlined, that means it's a man-made, synthesized element. For example, number 43, technetium, is a synthesized element. And so are ones basically from number 93 over to 103. Now, I'm talking about the periodic table in the classroom. So when you look at these colors, make sure you're looking at the one on the wall in the classroom. So metals are to the left of the stair step, except for hydrogen. So let's look at a periodic table. On a periodic table, if you don't have a stair step drawn in, you can go ahead and draw it in. It's basically, get a different color here. It's basically right here. There's your stair step. So if you don't have a stair step drawn in on your periodic table, you can go ahead and draw it in. Anything to the left of the stair step is a metal. So we're talking about all of these elements over here are metals. Now I know hydrogen is over here, but hydrogen is a nonmetal. Hydrogen is a gas, it's a nonmetal. So about 80% of the periodic table, all these over here plus the ones at the bottom, are metals. Nonmetals are located to the right of the stair step. Most of these are gases at room temp. Gases, if you go back to the periodic table, if it's outlined in red, it's a gas at room temp. And again, I'm talking about the periodic table on the wall in the classroom. There are some solids. There's also one liquid, and that is bromine. It's a dark red liquid at room temp. Now, nonmetals, they're poor conductors of heat and electricity, except for carbon. And there's a great variation in physical properties because some are solids, some are liquids, some are gases at room temp. They react differently. Great variation in physical properties for these nonmetals. And then the third category that we can group elements into are metalloids. So you have metals, nonmetals, and metalloids. Metalloids have properties similar to metals and nonmetals, so they kind of fall in the middle there. And they're located right on the stair step, except for aluminum and polonium, which are metals. So go back to the periodic table, and again, we can kind of draw in this stair step here. Starts up here. If it's on the stair step, it's a metalloid, except for aluminum. Aluminum is on the stair step, but it's a metal. So boron is a metalloid, silicon, germanium, arsenic, antimony, tellurium. Polonium is a metal, and astatine would also be considered a metalloid. So those are your metalloids. It has to be right on the stair step in order to be considered a metalloid.